Okay. 10.4, the chain rule. It's just another derivative rule. We had the product rule, we have the quotient rule, and now we have the chain rule. So if g of x is a differentiable function and n is any real number, then the function u of x to the n, given the function u of x to the n, the derivative is going to be n times u to the x to the n minus 1 times the derivative of the inside function u of x. So to keep chain rule really, really simple, we say you are going to take the derivative of the outside. The inside function will remain the same, and you're going to multiply it by the derivative of the inside. So again, just say derivative of outside times the derivative of the inside. That's as easy as we can get. Derivative of outside times the derivative of inside. Okay. So that's the chain rule formula we will follow. Some more formulas are for e to the x and the natural log of x. So if we have e to the g of x, then the chain rule derivative for e to the g of x is going to be e to the g of x times the derivative of g of x, g prime of x. And that's the chain rule derivative for e to the g of x. And then the derivative for the natural log of g of x is going to be 1 over g of x times the derivative of g of x. Or you can put it simply, put the chain rule derivative for the natural log of g of x is just going to be g prime of x over g of x. So the derivative of the inside over the inside. Okay, so we'll use these formulas as we go along. So let's do this. So starting with A, find the derivative of f of x is equal to 3x plus 1 to the 4th. Okay, so our derivative, f prime of x, this 4 is coming down. So our chain rule derivative is going to be 4 times 3x plus 1, and we take 1 away from that 4. So you're going to get 4 times 3x plus 1 to the 3rd, and then you're going to multiply it by the derivative of the inside, which is going to be just 3. So again, derivative of outside times the derivative of the inside. Okay. And all we have to do is clean up. So I'm just going to multiply the 4 and the 3 together, and that'll be it. So we're going to end up with f prime of x equal to 12 times 3x plus 1 cubed, and that is the chain rule derivative for the above function. Oops. All right. Any questions on that? Derivative of outside times derivative of inside. Okay, cool. Let's keep going. B, find y prime if y is equal to 3 times x cubed plus 4 to the 7th. Okay, again, y prime, and we take the derivative. This 7 will come down and multiply that 3. So you'll get 21. The inside will stay the same, and you'll take 1 away, which means we'll get 6. There's the derivative of the outside. Then we multiply it by the derivative of the inside, which is going to be 3x squared. And there it is. Derivative of outside times derivative of inside. And now I'm just going to multiply these two numbers together. And we'll get y prime equals 63x squared times x cubed plus 4 to the 6th. Done and done. Okay. All right. Keep going. C. 4x plus 3 to the 1/2. So we do it again. Chain rule derivative. That 1/2 comes down, and we get 1/2 times 4x plus 3. We subtract 1, and 1/2 minus 1 gives me negative 1/2. And there it is again, the derivative of the outside, and then multiply it by the derivative of the inside, which is just 4. Okay, so there it is. Derivative of outside times derivative of inside. Multiply these two numbers together, and we get 2 times 4x plus 3 to the negative 1/2. Now that's a great answer, or you could rewrite it as 2 over 4x plus 3 to the 1/2. Okay. All right. All good?
Excuse me, sir. Quick question.
Yes.
I hate to interrupt, but unfortunately, I can't join for the rest of the class. So I was wondering how the attendance worked for like the online class.
Oh, like I said, once you log into Zoom and just say hi, it logs you in for attendance already.
Okay. Thank you, sir.
So since you're here, I'll count you for attendance.
Thank you. Have a good day.
You too. Okay.
Oh, wait, why did you multiply that equation by 4?
Because that was the derivative of the inside.
Okay.
All right. What else? Any other questions on this one? Okay. So remember, it's always derivative of outside times derivative of inside. So that's what we're doing there. Okay. Again, of course, more practice. So the derivative, f prime of x, that negative 3 comes down, and you get negative 3 times x to the 5th plus 2, and you subtract 1, and that means we go more negative. So there it is. There's the derivative of the outside. Now we multiply it by the derivative of the inside, which is 5x to the 4th. So derivative of outside times derivative of inside, and then again, just multiply these two numbers together. And f prime of x is equal to negative 15 x to the 4th times x to the 5th plus 2 to the negative 4. And that's it. Again, one more rewrite is negative 15x to the 4th over x to the 5th plus 2 to the 4th. All right. Any questions on that one? All right. Let's keep moving. E, d over dt of 1 over t squared plus t plus 4 to the third. So we could take the derivative in this form using the quotient rule, but sometimes it's just a lot easier to rewrite it. So let's just rewrite this as d over dt of t squared plus t plus 4 to the negative 3. All I did was flip it up, and it's going to make the derivative a lot easier. So that means we can take the derivative, and when we take that derivative, that negative 3 is coming down. So we'll get negative 3 times t squared plus t plus 4. You subtract 1, and we get negative 4. So there's the derivative of the outside. And then multiply it by the derivative of the inside. So this one's going to be 2t plus 1. So there it is again, derivative of outside times the derivative of the inside.
It's 2t plus 1 because t, derivative of t will be 1.
Very good.
Okay. Just making sure I was
You got
following.
it. And then this times that. And we get, I'm going to just write it like this first. Negative 3 times 2t plus 1 times t squared plus t plus 4 to the negative 4. Okay. So that is a good answer. Not sure if my math lab wants you to distribute that negative 3, but first off, I'll box this. Another suitable answer would be negative 3 times 2t plus 1 over t squared plus t plus 4 to the fourth. And if you really have to, you can distribute that negative 3 and get one more answer. But I don't think you have to. Okay. Any questions on that one? All right. We're moving. All right. Find dH over dW, so find the derivative if h of w equals the square root of 3 minus w squared. So we definitely have to rewrite this one before we take the derivative. And since this is just the square root, we can rewrite this as 3 minus w squared to the 1/2. Which means now we can find the derivative by using the chain rule. And I'll just use the notation it wants, dH over dW. And this 1/2 is coming down. So 1/2 times the inside, we subtract 1. And again, 1/2 minus 1 gives me negative 1/2. So there's the derivative of the outside. Now we multiply it by the derivative of the inside, which is negative 2w. Okay, and just clean up. 1/2 times negative 2w. We will get negative w times 3 minus w squared to the negative 1/2. And again, that is an perfect answer, or negative w over 3 minus w squared to the 1/2. All right. How we doing?
I'm waiting for the hard part.
Maybe we're just making it seem too easy, right? Okay. Okay. Still moving. So find the derivative if y equals 2 times x cubed plus 6 to the fifth. So y prime is equal to this 5 comes down, multiplies the 2. We get 10 times x cubed plus 6. You take that one away. So that's going to be to the fourth. Again, that's the derivative of the outside. Now we multiply it by the derivative of the inside, which is 3x squared. All right. And once again, multiply that number by that number, and we get 30x squared times x cubed plus 6 to the fourth. All right, not bad. All right. Same thing here. D over dt of 3 times t cubed plus t squared to the negative 2. So chain rule derivative. This negative 2 comes down and multiplies the 3. So we are going to get negative 6 t cubed plus t squared. Take that 1 away to the negative 3. There's the derivative of the outside. Now we want to multiply it by the derivative of the inside, which is going to be 3t squared plus 2t. Clean it up, and this 6 times that inside derivative, and I'll rewrite it as this first. Negative 6 times 3t squared plus 2t times t cubed plus t squared to the negative 3. And once again, that is a perfect answer, but if you are asked to rewrite it, then our rewrite would just be negative 6 times 3t squared plus 2t over t cubed plus t squared cubed. And again, if it makes you distribute the negative 6, then just distribute it. Okay. All right, now some fun ones. Okay. So I says d over dx of 2x squared times x cubed minus 3 to the fourth. So since there are two terms inside, we get to use the product rule. So this is going to be a product rule that involves a chain rule. So this first function will be f. The next function is g. And now take the derivative of f and g for x Now on G, we have to use the chain rule. So when we use the chain rule, you'll get 4 times x cubed minus 3 to the third times the derivative of the inside, 3x squared. So let's go ahead and clean up G prime, because again, we'll just multiply the 4 and the 3x squared. We'll get 12x squared times x cubed minus 3 to the third. All right, now we are ready to follow the product rule. So we just did a product rule and a chain rule, but we still have to finish using the product rules formula. So I'm just going to write the same expression again, d over dx of 2x squared times x cubed minus 3 to the fourth. And now let's follow our product rule. F prime g, 4x times x cubed minus 3 to the fourth plus g prime f. 12x squared times x cubed minus 3 to the third times 2x squared. All right. Now, lots of cleanup. So, well, almost a lot of cleanup. We can't do anything here. You cannot distribute the 4x into those parentheses because of that power of 4. The only thing we can do here is multiply those two numbers. So this will stay the same. And 12x squared times 2x squared gives me 24x to the fourth times x cubed minus 3 to the third. Now, I don't know if it'll take that as an answer. I may have you factor it. So let's go ahead and just simplify this a little bit more by looking at greatest common factors. So here I have a 4, and here I have a 24. The greatest common factor here is 4. And then I have an x and an x to the fourth. My greatest common factor here is just x. And then last, I have x cubed minus 3 to the fourth and x cubed minus 3 to the third. My greatest common factor there is x cubed minus 3 to the third. Now this is our greatest common factor, and that means we are going to factor this term from both of these terms. So when I factor it, when I take 4x from 4x, those will cancel. When I take x cubed minus 3 to the third from x cubed minus 3 to the fourth, all will cancel but 1. So I will be left with just 1 x cubed minus 3. And now we do it again. 4 from 24, 4 factored from 24 will give me 6. X from x to the fourth, factored from x to the fourth, will give me x cubed. And then x cubed minus 3 to the third from x cubed minus 3 to the third will cancel. So all I'm left with is just 6x cubed. Now, combine like terms inside. I'll first rewrite that. And I see that I have an x cubed here and a 6x cubed there. So this will make 7x cubed minus 3. And now there's our final answer. Yeehaw. Any questions on that one? That one's definitely your algebra overload. Okay. Let's keep moving then. Now here we get to use our special chain rule formulas for e to the x. So remember that if you have, let's say, d over dx of e to the gx, then your chain rule derivative is e to the gx times g prime of x. Okay. So that means that for our function here, when we take the derivative, I'll keep that -5 outside. And all we're looking at is the derivative of e to the 12x. So using this chain rule formula, the derivative of e to the 12x is still going to be e to the 12x times the derivative of that function 12x. So the derivative of 12x is just 12. So there's a derivative. And now all we have to do to clean up is multiply that 5 by that 12. And we will get -60 e to the 12x. There it is. Any questions on that one? Okay. And now, again, we have the natural log. So the derivative, so again, if we have the chain rule derivative of the natural log of some function g of x, then the chain rule derivative is going to be just g prime of x over g of x. G prime of x over g of x. Okay. So for this derivative, do this in purple, the 10 is going to stay there. So we're going to say 10. And then all we're taking is the derivative of the natural log of x to the 9 plus 2. So what we're going to do is take the derivative of the inside, which is 9x to the 8th, and put it right back over the inside function, x to the 9th plus 2. There we go. Now just multiply the 10 in, and you'll get 90x to the 8th over x to the 9th plus 2. Okay, that's not bad. All right. Any questions on that page?
Nope, just gonna have to rewatch it.
All right. Okay. And last one. Cool. So the total cost in hundreds of dollars of producing X cameras per week is given by the cost function C of X equals 6 plus the square root of 4X plus 4, where the domain is between 0 and 30 cameras. Find C prime of X, and then find C prime of 15 and C prime of 24. So we're going to find the derivative. And then in step B, we're going to plug 15 and 24 into the derivative. Okay. So let's start with A. C of X equals 6 plus, and we're going to have to rewrite the square root. So this would be parentheses 4x plus 4 to the 1/2. So we have to write it from radical to exponent, rational exponent. And now we take the derivative, and the derivative of 6 is 0, plus, and now we have to do the chain rule on 4x plus 4 to the 1/2. So that 1/2 comes down. The inside stays the same. You subtract 1 from the original power, and 1/2 minus 1 is negative 1/2. And again, that's the derivative of the outside. And then you multiply it by the derivative of the inside, which is just going to be 4. Okay. And then clean up. That 0 goes away, and we just multiply that 1/2 and the 4. So C prime of X is going to be 2 times 4x plus 4 to the negative 1/2. Now again, that's good. Or you can rewrite it as 2 over 4x plus 4 to the positive 1/2. Okay. Now all that's left to do is plug in 15 and plug in 24 and interpret. So B, C prime of 15, C prime of 24, and let's use Desmos. Why not? All right, so I'm just going to type this function in. 2 times 4x plus 4 raised to the negative 1/2, so negative 0.5. And then I'm going to just change it into a table, makes computing faster, and type in 15 and 24. And I get 0.25 and 0.2. Okay, perfect. So we have the cost function. We've taken the derivative of the cost function. So remember, now we're dealing in slope. And 0.25 and 0.2 were both positive outcomes. So what this problem is saying is that the total cost in hundreds of dollars of producing X cameras per week. So what we're saying is that if we produce 15 cameras, the cost is going to increase by how much?
25 cents.
25 cents. But remember, this is in hundreds of dollars. So if we multiply that by 100, we'll get what?
25.
25, right? So at 15 cameras, cost will increase by $25 per camera. And then if we produce 24 cameras, cost will increase by $20. And that's it. And that is the chain rule. So, any other questions on that?
Do businesses actually have cost functions like that? How do they build those?
So